space you're going to work. It might be a global, those kind of things. Okay, so this first part has a bit of significance. That is parts of function f5. Okay, so now we'll just break down into one by one. We'll just go into the first one, parts of function m5. Okay, so if you take the parts of function m file, there are 5 classifications. These 5 things forms the programming part of a function m file. Okay, that is function definition line. First one is function definition line. Second one is h1 line. Third one is help text. Fourth body, and the fifth one is comments. Okay, so imagine you're writing a program. Your program should have this 5 things. That's what they mean to tell. Okay, these 5 things forms your basic programming of a function m file. The first one is your function definition line, h1, help text, function body, and comments. Okay, and for that, what they have done is they have given a program also. They have given a program to illustrate how these 5 parts are being broken inside a function. Okay, we'll see that example. Yeah, just watch this example. Write a function to calculate the roots of a quadratic equation. Okay, this is a root of a quadratic. I mean, you have to calculate the roots of a quadratic equation where a comma b comma c are the constants. Okay, in the equation you have this a b c, they are the constants. So as I said, see this this file name roots1.m. Okay, containing the function root is created. First, what you have to do is you have to create this function. See, this is the what to say, this is a primary function. Okay, so this function calculates the roots of a quadratic equation. So like this, what is being given is there are some different steps which is being given. Just watch the program. See, you have this this function r. Okay, different functions are being given here, and this disc. Okay, this part is there. I'm pointing the cursor, isn't it? So this part is for calculating the discriminant. That is this part. This is equal to, okay, b square minus 4ac. Calculate the discriminants. And this disk 1, this line, what it does is it finds the square root of the discriminant. Okay, because you know how to calculate the square root, isn't it? So I'm not going to go into the mathematical formula. So this first equation tells about calculating the discriminant. The second equation tells about finding the square roots of the discriminant. And the third one is R1. R1 is equal to, you're able to see, isn't it? This R1 calculates the first root and this R2 calculates the second root. Okay. And see, we have seen this 5 classifications, isn't it? Function definition line, H1 line, help test, function body comments. Now we are going to see those 5 types. Okay. So once when you do this, the above function roots1 can be called. Already we have seen here, isn't it? We have created roots1.m, right? So roots1 can be called by giving the following command in the command window. You go to the command window and you give this command, I mean above function roots1. So once we give this roots1, what happens? Let a is equal to 1, b is equal to 4, and c is equal to 4. What happens? The values will be executed. You'll be getting the values of root1 and root2. You can run this and try. Now this basic program, what is being given is how this 5 parts of m function is being broken. Just check out. Yes, the first is function definition line, right? What is a function definition line? In the program, you would have noticed this function output arguments minus function underscore. This thing indicates the function definition line. Okay, this one is your function definition line, right? And the second one is, I mean, they are given some examples also. The function definition line of a circle. How you can save is by the name circle underscore area dot m. And function rectangular underscore area, how you can save is rectangular underscore area dot m. But remember students, all your function files should be saved in the extension of dot m. Okay, whenever you are storing a function and you are calling the primary function inside a sub function, obviously your function file should be in the name of dot m extension. Okay, have that in mind. Okay, so this is some examples. The second is h1 line. Okay, so if you're going to see this h1 line, h1 is the first line, right? Just watch out the program. In the program, you would have seen this line. This function calculates the roots of a quadratic equation. So this is called as the h1 line in the program. This is the line is the first line. Okay, this you can compare with the program in the previous slide and understand where it is coming. Okay, so this is about h1 line. The third is help text. In the program, you would have noticed some help text. That is, These three lines you would have noticed in the example 8.2. What are those three lines? This function calculates the roots of a quadratic equation. A, comma, B, and C are the input arguments. R1 and R2 are the output arguments. Like this, you would have seen some help text. Okay, so these all three lines constitute the help text of the example program. Okay, and the fourth one is function body. Sorry, it is not clear. Really sorry. We have discussed about the function body, isn't it? There's four lines. The first function is for calculating the discriminant. The second function is for finding the square root of the discriminant. The third is for calculating the first root, the third line. And the fourth one is for calculating the second root. This is a very important part of the function. Okay, this is your function body. So this four lines helps in calculating the roots of a quadratic equation. So this forms a very important thing. And the next one is comments. Yeah, see, you could see the comments, right? So these are the comments. On the right side, you're able to see, isn't it? Calculating discriminant. With respect to the lines, we write the comments. Okay, so these are the 5 important classifications which sits inside your program. So as I said, this 5 important things forms very important in finding out the function. Okay, so the second thing is function names, right? It's something about the file name, right? How do you do and those things. I have put some lines, you can read this. Okay, so it is not that much clear, just bear with me. It tells about how the function names to be created. Okay, so this is about the function names. And the next one is passing function arguments. Okay, as I said, this is also not that much into coding. So it tells about how to pass a value between the primary function and the sub functions. Okay, this is about the function arguments. And the fourth is about the function workspace. As I said, isn't it? This M file variables take separate memory space from the MATLAB. This is called as function workspace, right? Whenever you're using a M file, function M file, if you take the MATLAB, there will be a little bit of memory space utilized, and that is called as a function workspace, right? And you know about the global variable declaration. So the following command is used to declare the variables as global. Okay, so global x comma y comma z. In your C language, you study about global and local variables, isn't it? So the same thing concept works over here. So these are the very important concepts of how your function is being broken into different parts. And now what is being given in your textbook is some basic, not basic, some examples. Okay, so it tells about how the function. Some examples, how this function works. Okay, see this question to calculate the sum of following series. So the series is being given. You are able to see this is the function, and these are the function to calculate sum. Like this, it goes. So what I want you to do is, when you get your free time, take this program, run this. Okay, I have copied some programs with the output also. Just check. So this is about the calculating the series. I'm just running through it. Okay, and I have taken a one more program. Write a function subprogram to calculate the compound interest, CI, isn't it? So given the initial amount, time period, rate of interest, and time of computing. Okay, so try to solve this in finding out the compound interest. It's a kind of big one. Okay, somewhat it goes. First is use a function compound. COMP is called with the input arguments. So like that, it goes with the interest. So the definitions, everything is there, but you have to analyze this, how this coding is running. Okay, and the next one is write a function to check the division scored by number of students. Okay, you can give your you can set your values. The values are not being mentioned. Okay, you can set your values in the program. Okay, so this is about checking the division scored by number of students. This is one important thing, because this is all using a primary function and using a sub function. Okay, yeah, and one more program, it is being defined. Write a function to ask for a given number of lines and report if there are between 10 and 100 or not. What you need to do is, you need to write a function to ask for a given number of lines and report if they are between 10 and 100 or not. Okay, so this is the range. You can use a if statement when a is greater than 10 and a is less than 100. Okay, like this, you can set the parameter inside this function, and you can work on this. Okay, so this is about this is about the functions. Okay, so again I am telling you, students, whatever we have seen now, right? Whatever we have seen now, this I'll just include in your second unit, right? So because this also forms a bit of basic understanding of functions in your second unit, because initially whatever I have shared in the second unit PPT, I think the initial functions would have been about Scilab commands. Okay, if you have tried executing in the MATLAB, some programs it would have shown an error. Okay, even Abin was asking me, sir, I executed one program, I tried, it was showing an error. Okay, so that was all Scilab based. So again, now I am insisting we are literally moving into MATLAB, right? Because we have the command over in MATLAB. We are understanding the tool very fine about MATLAB. So why we again need to go into Scilab? That is why we need to find the equivalent. That is a big headache, isn't it? So we need not try that. Now we will try everything with respect to the MATLAB. Okay, so now my suggestion is, it's like you keep practicing your MATLAB very well. Okay, Scilab you understood as tool. That is one thing. Like you learned a new tool, like that you can keep it, and rest all trying and understanding right now. You just keep working on your MATLAB. Okay, so this I'll just add it in the Unit 2 PPT, and I'll share it in the GCR. Okay, so I thought with this, I'll just stop my presentation. That's all. I'll just finalize with the attendance, and we'll just wind off the class. Is that okay, students?
Yes.
Yes, sir.
Yeah, fine. Just hold on. I'll go with the attendance.